continue our PCI today. I'll do a quick recap what we learned yesterday. I promise today I will not spend too much time because I think we still have time. And after that, our next tutorial will be next week. We don't have tutorial for except group T04 because you all arranged with your Mr. Joel. The rest you don't have tutorial, and then the following week is Flex Week, also no tutorial. So by the time tutorial comes back, it's already like 3 weeks later. Okay, so I don't want to move too fast. So if not, some of you may forgot what you learned today. Okay, yesterday we learned about Laplace transform, right? And important part is this table. This side is actually the table for the function. Okay, and then your right hand side is actually the function for Laplace format. So if I have a function of this, Laplace become this, I inverse become like this. So any process dynamic normally will have dy dx or differentiation equation, and we will use this Laplace table to help us solve the problem. Okay, and remember we tried this example, right? What we have is phi dh dt plus 2h equal to 2. In order for us to solve it, first we Laplace it, right? How to get this Laplace? The dh dt, if you refer to the table, is sh minus h0 plus this one come from h, small letter h after, or what I call it, the functions after Laplace become capital letter. And then 2 is the unit function, right? Then after it's transformed, become 2 over s. So you convert a differentiation equation into normal algebra equations by transform the Laplace. Okay? After that, solve it by using either normal algebra way or solve it using partial differential. Then you will rearrange it and get like this. Okay? One condition is the h at time 0 is 0. That's why you eliminate the h0, the small letter one. So let's give you this final format in terms of S or the Laplace. After that, have to invert. How to invert? You have to use the table. We went through this example yesterday, right? So finally, this is the answer that you should have. How do we read this formula from this equation itself? Let's say the h is the water level in the tank. Let's say the h is the water level in the tank. This means that at any time, right? Let's say time t equal to 2. My water level is equal to 1 minus exponential of minus 2 over 2.5. Let's say t is 2. So that will give me a h, the water level. So at different time, the water level, let's say for this equation itself, I assume this is h of the water level in the tank, right? So which means that different time, after I minus out everything, I will know different water level. And if the water level change very fast with respect to the time, right? So I can say the process dynamic is very fast. Okay? This is why we need to use Laplace, because most of our process dynamic are in the differentiation equation. This helps us to solve the question easier. Right, example A. This one I think we can do it together. Okay. Alright, if I have an equation phi, let's see this side. Okay, if I have a process which is phi dy dt equal to t, alright? This is my process dynamic and equation I derive. Later on we will try to derive one of the process. At this point, try just to understand if I already have a differentiation equation to represent the process dynamic, how should I solve it, okay? And I always want you to refer back to this table. So this table is very important for us to solve this equation. Alright? Okay, so on this side, you just refer to the table. And this side, what we have is actually our differentiation equation. Phi dy dt equal to t. Okay, now I have phi. I need to Laplace it, right? I need to transform it in order for me to solve it. If I don't transform it, how do I solve this one? Can I solve this by normal integration? How? Okay. So how? Let's say for example, if I don't want to solve it by Laplace, we try. I never tried before. So let's say I got phi dy equal to t dt, right? Right? If I put the other side, dy equal to t divided by phi dt. Right? So if I integrate dy, I have to integrate this side also, right? Okay. This one becomes t squared divided by phi, right? And then this one becomes y. So eventually you will get something like this, right? Times 2, which is t power of 2 divided by 10, right? Is it the same answer we have? No. Same, huh? Right? T power of 2 divided by 10, right? Okay? This is normal solving the problem by integration, right? But if I don't want to use this normal way, I want to use Laplace. Because this equation itself is actually quite simple, easy for you to use normal integration. But sometimes you will have very complicated equations that you cannot use a simple integration. So in order for you to solve that, you use the Laplace. Let's us try the Laplace way to solve this. It's okay, huh? So I delete. Okay. Okay, Laplace wave 5 dy dt is actually, if I look at this table, dy dt is which one? Is actually this one, right? So after I transform it, I should have this. So what I have is 5 multiplied, because if I have a small letter f, I Laplace it become a big capital F. But if I have y, what I have here is s, still the s. S is just an unknown in Laplace format, so you just use the s. But what I have here is y, correct? And then after that, this one have a s, okay? Minus s, minus y 0, okay? Minus y 0 equal to, if I Laplace transform t, become what? 1 over s power 2, right? So I got 1 over s power 2, okay? The question also tells us that y0 is equal to 0, right? Correct? I didn't print it. Alright, so this one is equal to 0. So what I have here is phi s multiply y equal to 1 over s power 2, correct? Okay? So if I arrange only y at this side, I have 1 over phi s power 3. Okay? Any questions so far? This is exactly what we have on this side. Not this one. This one, okay? So why, either you want to put a small s here or without an s there, it's okay. For me, as long as you understand it, you know the capital Y, right? It's actually in a Laplace format. And Laplace format is not linked to t anymore, but it's linked to s. So whether you want to put an s here or without an s here, it does not really matter, okay? So y equal to 1 over 5s power of 3. By having this format, you already sort of complete what your Laplace and rearrangement that you want to do. Now you need to invert it back. In order for you to invert back, you must find your nearest, in the table, the nearest format to 1 over 5s power of 3, right? If you look at your table, that you have here, right? The nearest is which one? The nearest to 1 over s power of 3. 1 over 5, you can take it out, right? 1 over 5, you can take it out. What you have inside is s power of 3. On this table itself, which one actually nearest to 1 over s power of 3? Can I say this one? Or can I say this one? S power of 2 cannot, right? Because it's only 2. So let's say you take this one, right? So if I take this one, but the top part I have this n factorial, right? Divide by s plus n plus 1, right? In order for me to get rid of the n factorial, I must divide it, right? If I cancel out this one, if my s is 2 here, so 2 plus 1 is 3, it's back to exactly the same format that I have. Any question? Can, right? So in this case, n is equal to 2. So if I wanted to change it to that format, I should have 2 factorial divided by 2 factorial s 2 plus 1. Okay? Right? So in this case, n is 2. If I use this table itself, what I have is, if I invert it back, become t power of n, right? N is 2, so it's become t power of n. So what I have is 1 over 5 times 2 factorial. This side, right, the entire thing, invert it back, become t power of 2. Okay? And 1 over 5, 2 factorial is 2 times 1, right? And then this one is t power of 2. And this is equal to 1 over 10 times t power of 2. Okay? Which is equal to what we have, 1 over 10 t power of 2. Slow down a bit now. Okay. Slow down and repeat. Alright. Which part you want to repeat? Everything. Here? Wow. I also can. Okay. Okay, this is in differentiation form, right? Can? So phi dy dt is in differentiation form. I need to Laplace it. Okay? In order for me to Laplace it, I need to use the table. dy dt is actually the first dy dt is this one, right? If I have an f, then I have a big capital F multiplied by s minus small capital F at 0, right? So if now I have y, so I have s times y minus small y 0. This is what I have at this point. The entire this thing comes from I transform dy dt or dy dt. Okay? Alright? And the second part of this one comes from t power t. If I look at this table, t, which is this one, after transform it becomes 1 over s power of 2. So I have 1 over s power of 2, which is this one, okay? So this one become this one become this. Here? Okay, I don't want to make it very messy here, so I do it again. Alright, like this. So after transform, this is the equation I have. This is the equation I have. Now I know the question is actually telling you this small y at time t equal to 0. So this one become 5sy minus 0, 1 over s power 2, correct? Minus 0 I don't need to write, right? So I take it out. I only want to arrange y at this side. I put all the s at the other side. So y become 1 over, this one I bring it down, become 5s times s power 2. Okay? And this is equal to y equal to 1 over 5s power 3. This one, y become 1 over 5s power 3. Okay? So 1 over 5 power s power 3, right, is already the rearranged algebraic equation. Now I need to inverse back. How should I inverse? When I inverse, right, because I have all the s on your right hand side, I must check the Laplace table, which one actually nearest to the s arrangement I have. 1 over s power of 3, right? If I have s power of 3, if I take n equal to 2, so become s2 plus 1. The top here is 2, right? That's give me s power of 3. But if I have something on the top here, n factorial, but my original equation y, right, is without the n factorial on the top here. I only have 1 here. I only have 1 over here. Sorry. I only have 1 over here. I must multiply an n factorial, right? But if I multiply something, I want to get back to 1, I must divide it, right? That's the reason I have n factorial divided by n factorial. With the reason I want to arrange this one, n factorial divided by s n plus 1 into this format. N divided by s plus n plus 1. Alright? So if I divide n factorial, divide here, right? I can actually make it similar to this format. Right? And this n factorial divided by s n plus 3, right? I compare to that, I know my n is 2. Okay? Once I know the n is 2, I know this part is 2 factorial s2 plus 3. s2 plus 3 is s power of 3, right? And this cancel is still 1 over s power of 3, which is my original format. Okay? But 2 factorial divided by s power of 2 plus 1, when I invert it back, at this step, right, I managed to rearrange my formula into the table format that I want. Now I can start inverse. Okay? When I inverse it, I refer back to this side of the table. Right? Because I want to change it to t. I know n is 2, so it becomes t power of 2. So we have t power of 2. Just now I divide 2 factorial here. This one, I need to expand and multiply. 2 factorial is 2 times 1. The 5 is original in our equation. So I got 5 times 2 times 1, 1 over 10 t power of 2. This is my y at t. So any formula or any changes of y with respect to time will equal to time power of 2 divided by 10. This is what we need. Okay? If you look at the original, the first step I show you, right? We just do the normal integration, you will get back the same answer also. But Laplace transform, in this example itself, it seems longer. But most of the time, when you have more complicated differentiation equation, you will find Laplace transform is a very useful tool for you to solve integration question. Can yes. You mean this one? This one? Because I want to make it similar to what I have in the table. This one. Whatever you have on the S side, right, you must always arrange it to either 1 over S, 1 over S squared, 1 over S plus B, or this one, or this one. Only when you in this format, you inverse, right, you can get this. So you must always arrange your S into this side. When you practice more, yep. 1 over S cubed. No, what? You compare it with n factorial divided by S n plus 1. N is what? 2, right? 2. S is what? S is power of 1. 3, right? S is power of 3. So I must arrange it with S is power of 3, but I don't have any S with power of 3 here. If I put S with power of 3 here, which means that my N should be 2. If I have S power of 4, right, my N become 3, N become 3. If I inverse, become P power of 3. Okay? Please practice more and I'll show you more example. You will be able to see the trend. Okay? Shall we move to the next? Or you want to take a 5 minutes break? No need. I continue. Maybe I give you one more example, example B. Then the rest will continue maybe next week. Okay, shall we?
Dekat ni kan semua besar je diorang nak jual. Yeah, it's like kalau aku lagi panjat-panjat rosti sini. And it's a cushion.
So yesterday we see the example of 1 over tau S plus 1, then you invert. Just now we see n factorial S plus n. Now we're going to see another example. In this case, what we have is the differentiation equation is phi dh dt plus phi h equal to 2t, right? The condition given to it is h0 equal to 0. h0 and whatever function at time 0, right? Not always need to be 0, but in order for us to easier for us to calculate or show you the example, we always assume it as 0. Okay? So let's say in this example, let me open the slideshow. Alright. So if I have phi dh dt plus phi h equal to 2t, I need to Laplace it, right, using Laplace transform. Phi dh dt Laplace transform become what? S. This one is differentiation, right? Differentiation. Differentiation, you refer to the table is S, and then this h become h, capital H. Then minus 0, right? H0. Don't ask me why, just use the table. You always need to refer to this table, alright? So, dh dt equal to this one, okay? Plus phi, h become big, the capital one, right? Capital H. 2t become 1 over of s power of 2, right? So we can always write it as 2 on the top. And this one, because h0 is 0, so I take this one as 0. what left at this side is 5sh plus 5h equal to 2 divided by s power 2. Right? Okay. If I take out h on the left hand side, what I have is 5s plus 1, a plus 5, equal to 2 over s plus 2. Okay? Alright? Can And I want to have a capital H on this side, all the s on the right hand side. So h equal to 2 divided by s plus 2 multiply 5s plus 5. Okay? Once I arrange in this condition, we need to see from the table how to inverse it back already. Okay? 2 divided by s power 2 5s plus 5. The easier way to break it is actually use partial fraction, right? Actually, I can break this one into a divided by x plus 1. Remember yesterday I showed you b x plus 1, things like that, right? Okay, but in this case, how many factor I have at the denominator? I have 2, right? One is s power 2, one is 5s plus 5, correct?
Yes.
For 2 over s power 2, if you break it into partial fraction, because of power of 2, right, your top here, you must have an a s plus b. Okay? These two actually I can take it out. Okay, I just put it down here. Alright, plus c divided by 5s plus 5. This part, okay? This one, right? Break into this one. This one, break into this one. Alright? Okay? This one, when you break it, right? Why I got as plus b? Why not just a divided by s power of 2? Because anything power of 2, right? The top one should have the linear function. If you have power of 2, your top should have a linear function. If let's say I got 1 over s multiplied by, let's say, s plus 1. This one I can put a divided by s plus b divided by s plus 1. Okay? But if I have a s power of 2, right? This a should be as plus b, and then this one just 1. Okay? Do I need to repeat this part? Okay, let me repeat that. Last time when you all learned about partial fraction, right? I move up first and then come back. Our partial fraction, we learned about this. If I got 1 over x plus 1, x plus 2, I will have a divided by x plus 1 plus b divided by x plus 2. Correct? Okay? If let's say I got 1 over x squared plus 1, x plus 2. If I want to break it, right, it will become ax plus 1 divided by x plus 1 plus 2 plus b divided by x plus 2. Whenever the bottom is power of 2, your top here should have an x. Okay? If you refer back to the notes that you have, this is one of the examples that you definitely will see. Alright? Can? So I delete this one. In our case, because we got 2 s power of 2, right? So we must use this format. Okay? Too fast? This one's a partial fraction. If you go back and Google or find anything, so you will understand or you will able to get this format. So what we have is, we have 2 s power of 2, right? Because the s here, this is one factor. 5s plus 5 is another factor. So s power of 2, I know if I want to break it, right, my top should have as plus b. So s power 2 as plus b. These two come original from the question itself. So this is how I break the first part. And I left another factor here, 5s plus 5 is equal to c divided by 5s plus 5. Okay? Why I need to break it like this? Because once I break it like this, right, I can find from the table the nearest format. And before I can find from the table the nearest format, I must solve for A, B, and C, right? I must solve for A, B, and C this side. So I don't look at this one, I take out this one. So what I have here is 2 divided by s power 2 as plus b, the normal partial fraction way of doing it, right? 2 divided by this equal to s plus 5, alright? So let me see, this is, I need to find the as plus b. So this side, I write on your left hand side. So I have 2 divided s power 2 multiply 5s plus 5. This one can break it into 2 divided by as plus b divided by s power 2 plus c divided by 5s plus 5. Okay? Right? On this side onward, it's just a partial fraction, nothing to do with my Laplace. Okay? I just want to partial fraction it so that I can use the table. In order for me to find a, b, and c, so I cross multiply it. This one I keep it as it is. And this side I have 2.
I still don't get what is there 2. Plus. The top one got
2 as plus b multiply 5s plus 5 divided by s power 2 5s plus 5 plus c multiplied by s power 2. Correct? Okay, this part. This come from.
So why got 2
Where? These two
No, the other side.
CS power 2
No, the first 2.
This one don't have 2 man?
Yeah, don't have.
Oh yeah, because we don't need the 2, yes. This one delete, like that, right? Okay, so the top also we don't have the 2.
No.
Because this side have, but when we break it, we actually only consider the 5 as plus b, okay? This one. So now the bottom actually can cancel out. This one can cancel out, right? So what I left here is 2 equal to as plus b multiply 5s plus 5 plus cs power 2. Okay? Okay, so when I need to find A, B, and C, right, I need to assume the S value, right? Let's say if I assume S equal to 0, S is like our X and T. If S equal to 0, 2 equal to, this side all become B, and then time 5. This one 0, right? So B equal to 2 divided by 5 is 0.4. Okay? So what I have here is B equal to 0.4. Okay? Then after that, what is the next S value I can guess? Actually any value, right? If let's say I guess S equal to 1. S equal to 1, what I have here is 2 equal to A plus B multiply 5 plus 5 is 10, right? Plus C. Okay, I expand this one. I got 10A plus 10B plus C. right? B I know is 0.4. So 2 equal to 10A plus 4, right? Plus C. This is one of my equation, right? I assume if S equal to 1. Now I need to assume another S, right? Because over here I got A and C. I already know B, but I need to find A and C. How to find A and C? I assume first one S equal to 1. Let's say I assume S equal to 2, right? When S equal to 2, what is the formula I have? I always go back to this formula, right? So if I sum in S equal to 2, what's the answer I have? I should have 2 equal to 5A plus C multiplied 4 plus 5A plus B multiplied 2 plus 5B. Okay? And if I solve it, 2 equal to 20A plus 4C plus 10A plus 2B plus 5B. Okay? And this equal to 20 plus 10 is 30A plus C is 4C. 2 plus 5 is 7B. Okay? I know the B value is B is 10, sorry, 10. Sorry, I did some mistake here. Is 20 plus 4C plus 10A plus 10B. This one is 10B. 10B. Okay? 10 plus this is 50. 15B. Okay? And this equal to 2 equal to 30A plus 4C. If I put in my B, which is 0.4, right? 15 times 0.4 is 6. This is my second equation. The reason why I expand this one is I must assume an S value in order for me to solve A and C. So when I have equation 1 and equation 2, right? If I solve it, these two equations only have A and C. I can solve it, right? Two equations, two unknown, I can solve it. If you solve it right, you should get A equal to minus 0.4 and then C equal to 2. Okay? Yes? Where is 2B? Is it 10B or what? 2 lah, correct. This one. Back to this equation. When S equal to 2, right, is 2 times 2A plus B multiply 10 plus 5 and then 2 power 2 is 4C, right? This is what I have. Is it correct? No. Above. Whatever. 5A plus C, 5A plus C, right? This is my equation. Then S power 2, and I assume S equal to 2, 2 power 2 is 4. So, I cannot see it.
10A plus 10B should be 10A plus 2B.
This one. 10A plus 2B.
Yeah, you wrote 10A.
2B, right? Then after that you plus it to... Sorry. 2 equal to... Korean, what's the problem? This one wrong. How to get this up? Okay, we do it together again. We do it.
You can just do -1. Why do this multiplication?
It's the 5B part,
You can
right?
just
That's
put
what you're
-1.
doing.
But yeah, it's the 5B.
So we have 2 equal to S plus B plus C S power. This one correct, right?
Yes.
Then if s equal to 1, I have s 2 equal to a plus b, correct? And then 5 plus 5 is 10 plus c. This is equal to this equation, correct? Right? So if s equal to 2, I have 2 equal to 2s plus b multiply 2a, okay, 2a plus b multiply 10 plus 5, yes. Then 4c, correct? Correct. Then this one become 20a plus 10a plus 10b plus 5b plus 4c, 2, correct? And this is the second one I have, correct? This is my second one. And 2 equal to, this is 30a plus 15b plus 4c, correct? 5a, why I sub s equal to already, man? Is there any mistake? Anyway, what you want to do is, okay, somehow you need to find a equal to 0.4, c equal to 2, can? So what I have is a equal to minus 0.4, c equal to 2, and b equal to 0.4, right? And this one, I need to sub it back to my original equation. The original equation I have is this one, right? The as plus b divided by s power of 2, h equal to this, plus c divided by 5s plus c, alright? The a is minus 0.4s plus b is 0.4 divided by s power of 2 plus c is 2 divided by 5s plus 2, okay? This is the reason. Once I find a, b, and c, I put it back. My Laplace format is minus 0.4 plus 0.4 divided by s power of 2 plus 2 divided by 5s plus, this is 5. Okay. Oh, this one is not c, this is 5. Meaning I'm very tired already. Can you see? I'm human also, right? Okay. I don't admit sometimes. Anyway, so once we have this format, minus 0, I presume you all know how to find the ABC. Okay, I don't want to mess up myself here. So once I have 0, minus 0.4s plus 0 this, and this is 1, right? I need to find from the table. If I break this one, what I have is 0.4s divided by s power of 2 plus 0.4 divided s power of 2, right? Plus 2 divided by 5s plus 5. This is the 3 term if I break it up, alright? And this part can cancel. I have minus 0.4 divided by s. This is h. This is 0.4 divided by s power 2 plus, I always want to have the format 1 divided by something. So 2 on the top here may not be able for me to find from the table. So I divide by 2, I have 1 divided by 2.5s plus 2.5. Okay? So when I inverse this part, I have minus 0.4. Inverse of 1 over s is what? The table is 1, right? If you look at the table, this one, okay? If I inverse 1 over s, I get unit step. Unit step means it's 1. And originally I got 0.4. So 0.4 multiplied 1 is minus 0.4 plus S power of 2, if I inverse it back, is
T.
t, right? So I got 0.4 t. And 1 over 2.5s plus 2.5 is equal to this one, right? 1 over 2.5 plus 2.5 is this one. So if I inverse it is 1 minus this one. Correct?
Sorry.
Correct. So I got this one. And what is my tau value? 2.5, right? So I got 1 minus e power of minus t divided by 2.5. Okay? Of course, this one, after that, you can simplify and further. This is how we have this last part. No, actually it's divided by 5. Sorry. It's divided by 5. So 1 divided by 5 is 0.4. I got s plus b. B is 1. So 0.4 divided by s plus 1 is actually, if I look at the table, it should be this one, right? 1 divided by s plus b, alright? So if I reverse it back, is e power of minus bt. So the b is actually 1 over here. So I got e power of 0.4 is here, e power of minus bt, which is minus t. Okay. Very tired. Huh? Maybe I not enough sleep yesterday. Quarrel with my wife. Okay. Poor thing, you must pity me, right? Okay, sympathy me and forgive me for this one. Yesterday quarrel with you. Anyway, any question? Okay, huh? We can discuss more during the tutorial, honestly. I will go back and, I will, next week we can try to revisit this example again. Okay? Alright, thank you so much and thank you for those who highlight the problem. Okay? Thank you. See you all next week.
Sorry.